Welcome to our latest video on the topic of amines, nomenclature, classification and physical properties. This video is suitable for A-level students. By the end of this video lesson, you should be able to use the IUPAC rules to name and draw the structural formulae of amines and be able to classify the amines as either primary, secondary or tertiary. You should understand the intermolecular forces present in amines and how these are linked to physical properties such as boiling points. And finally, it should be explained why amines with short hydrocarbon chains dissolve in water and why increasing the hydrocarbon chain in an amine reduces this solubility. So now let's look at what we mean by the term amine. Now, amines are another homologous series that we study at A-level, and amines are nitrogen compounds in which one or more of the hydrogen atoms in ammonia, NH3, is replaced by an alkyl group or an aryl group, such as a benzene ring. And the number of alkyl groups determines whether the compound is a primary amine, a secondary amine, or a tertiary amine. So for example, if we look at the diagrams here, if we have an alkyl group attached to a nitrogen and two hydrogens, that is classed as a primary amine. This is because I've replaced one of the hydrogens in ammonia by one alkyl group. And if we have an alkyl group attached to a nitrogen and another alkyl group and one hydrogen, that is a secondary amine because I've replaced two of the hydrogens in ammonia by alkyl groups. And finally, a tertiary amine has all three of the hydrogens in ammonia replaced by alkyl groups. So now let's look at some examples of amines. The first amine drawn here is methylamine. We have a CH3 group, a methyl group, attached to an NH2 group. Now methylamine is classed as a primary amine. This is because if we take ammonia, NH3, the difference between methylamine and ammonia is one of the hydrogens is being replaced by an alkyl group, a methyl group. And as only one of the hydrogens in ammonia has been replaced by an alkyl group, it's classed as a primary amine. In the second example, we have dimethylamine, and this is classed as a secondary amine because two of the hydrogens in ammonia have been replaced by alkyl groups. And here's another example of an amine. Trimethylamine is classed as a tertiary amine, as all three of the hydrogens in an ammonia molecule have been replaced by alkyl groups. And in this case, there are three alkyl groups attached to the nitrogen. Now note that at A-level, you only be expected to name simple amines where the hydrogens are replaced by the same alkyl groups. Now it's also worth pointing out that at A-level you are also likely to come across amines where the NH2 group, the amino group, are found in the middle of chains. Now in this case you just number the chain starting at the end nearest the amino group, the NH2 group, so that the substituent, the NH2 group, is allocated the lowest possible number. So if we look at these two examples, in the first example I have a 3-carbon chain, and the NH2 group, the amino group, is on carbon 2. So this is called 2-amino-propane. And if we look at the next example, I have 6 carbons in the chain, and the NH2 group is on carbon 3, so this is called 3-amino-hexane. So now have a go at these practice questions. So here's the first practice question. We want you to name the following amines and state whether they are primary, secondary or tertiary. So pause the video, have a go at it, and then we'll go for the answers. And then we'll have a go at some more questions where I'm going to get you to name the following amines and state whether they're primary, secondary or tertiary. So now let's go for the answers. So compound A is called butyl amine because we have C4H9, a butyl group attached to an NH2 group, and it's classed as a primary amine because one of the hydrogens in an ammonia molecule, NH3, has been replaced by an alkyl group, in this case a butyl group. Now compound B is a tertiary amine because 3 of the hydrogens in ammonia have been replaced by alkyl groups, and the alkyl group that it's replacing the hydrogen is an ethyl group, and there's 3 of them, so it's called triethyl amine. So here are 2 more amines we'd like you to name and classify. Pause the video, have a go at these questions, and then we'll go for the answers. So compound C is called propyl amine because we have C3H7 attached to an NH2 group, and C3H7 is propyl, and it's a primary amine because one of the hydrogens of ammonia molecule, NH3, has been replaced by an alkyl group, and this alkyl group is a propyl group. Now compound D is a secondary amine, and this is because 2 of the hydrogens in ammonia have been replaced by alkyl groups, in this case ethyl groups, C2H5 groups, and this compound is called diethyl amine. So here are 2 more amines we'd like you to have a go at naming and classifying. So pause the video and have a go at these questions, and then we'll go for the answers. So now let's go for the answers. So for compound E, we have a 5-carbon chain, and we have an amino group, an NH2 group in the middle of this chain, and it's on carbon 3. And therefore the compound is called 3-aminopentane. Now 3-aminopentane is also a primary amine because only 1 hydrogen from the ammonia, NH3, has been replaced by an alkyl group. So it's a primary amine and it's called 3-aminopentane. Now for compound F, we have a 5-carbon chain again, and the amino group, the NH2 group, is on carbon 2. So this compound is called 2-aminopentane, and once again it's a primary amine because only one of the hydrogens in ammonia, NH3, has been replaced by an alkyl group. So now let's turn our attention to the physical properties of amines. Now amines are characterized by having fishy smells, and this is because when fish rot, their proteins are decomposed to di- and triamines. So that's why if you have an amine, it usually has a very fishy smell. Now amines are also polar molecules because there is a dipole between the nitrogen and the hydrogen. So the nitrogen is delta minus and the hydrogen is delta plus because nitrogen is a more electronegative atom than hydrogen, and therefore primary amines can form hydrogen bonds to one another using their NH2 groups. Now hydrogen bonds can form between the lone pair on the very electronegative nitrogen atom and the slightly positive hydrogen atom in another amine molecule. Now in this diagram I've drawn 3 primary amine molecules, and you can see that the hydrogen bonds form between the delta negative nitrogen atoms and the delta positive hydrogen atoms on another amine molecule. And notice that in an amine there's 1 lone pair on the nitrogen that is contributing to the hydrogen bond. Now just like other homologous series that we've studied, as the amines get longer, there are more carbon atoms, there are more electrons, and there are more van der Waals forces. So the boiling point of amines increases as the hydrocarbon chains get longer. So for example, ethylamine has a higher boiling point than methylamine. Now amines have higher boiling points than compounds such as halogenoalkanes, alkanes and alkenes that we've studied previously. And this is because hydrogen bonding is the strongest intermolecular force. And these other molecules, these other compounds, have weak van der Waals forces between their molecules. However, the boiling points of amines will be lower than comparable alcohols and carboxylic acids because nitrogen is less electronegative than oxygen, and therefore the hydrogen bonds are not as strong. An NH bond is not as strong a dipole as an OH bond. And that means, as you can see from this table, that the amines have boiling points quite a bit lower than the corresponding alcohols. So for example, methylamine has a boiling point of -6 degrees C, methanol has a boiling point of 65 degrees C, ethylamine 16.6, ethanol 78. Now the boiling points of primary amines are higher than secondary amines, and this is because of a decrease in the strength of the hydrogen bonds. And in a secondary amine, the NH bond is in the middle of the chain because there's two alkyl groups either side of it. And this means that the permanent dipole between the N and the H is not as strong, and as a consequence, the hydrogen bonds in secondary amines between their molecules are not as strong. Now a tertiary amine has a much lower boiling point than a primary or a secondary amine because it can't form intermolecular hydrogen bonds between its molecules because there are no NH bonds in a tertiary amine because there's three alkyl groups attached to the nitrogen. So now we've looked at boiling points, our final physical property that we're going to look at is solubility. Now amines with small chain lengths up to about 4 carbons long are very soluble in water, and this is because they can form hydrogen bonds with water molecules. Now even though tertiary amines can't form hydrogen bonds with other tertiary amine molecules, tertiary amines can form hydrogen bonds to water. Although the tertiary amines don't have a hydrogen atom attached to the nitrogen, they can form hydrogen bonds with water molecules just using the lone pair on the nitrogen. So this diagram shows ethyl amine forming hydrogen bonds to water, and you can see that the delta negative nitrogen with the lone pair is forming a hydrogen bond to the delta plus hydrogen on a water molecule. And the delta plus hydrogen on the amine can form a hydrogen bond to the delta minus oxygen on a water molecule. Now, similar to other homologous series that we've studied, the longer the non-polar hydrocarbon chains, the more it disrupts water's ability to form hydrogen bonds to the NH2 group. So in an amine, the longer or larger the alkyl chain is, and the more alkyl chains you have, so for example primary, secondary, tertiary, the less soluble the amine becomes. So now let's test your knowledge of physical properties with some practice questions. So read through the questions, pause the video, have a go at them, and then we'll go for the answers. So now let's go for the answers to question 1. So question 1 is asking you to explain whether boiling points of primary amines increase as the hydrocarbon chains get longer. And this is a 2-mark question. So the longer the hydrocarbon chain, the more electrons and the more van der Waals forces are present. 1 mark for that. And this means more energy is needed to pull the molecules apart. And there's 1 mark for that idea. So that's why the boiling points of primary amines increase as the hydrocarbon chains get longer. Now for part B is asking you to explain why tertiary amines have a lower boiling point than primary amines of the same molecular weight, and it's because primary amines have hydrogen bonds between their molecules and tertiary amines do not. They have van der Waals forces between them which are much weaker. So that idea gets you 1 mark, and hydrogen bonds are the strongest intermolecular force, 1 mark for saying that, and therefore more energy is needed to pull the molecules apart, and that's why primary amines have a higher boiling point than tertiary amines. So there's 3 marks for that question. So here's the second question for you to have a go at. So read through the question, pause the video, have a go at it, and then we'll go for the answer. So question 2 is asking you to draw a diagram to explain why the primary amine, methylamine, dissolves in water. So I'm going to draw this diagram for you. So methylamine has a CH3 group attached to an NH2 group, and it's classed as a primary amine because there's one alkyl group replacing a hydrogen on an ammonia molecule. So I'm going to draw my methylamine, I'm going to put my lone pair on the nitrogen, and I'm going to put the delta minus charge on the nitrogen and the delta plus charge on the hydrogen. And then I'm going to draw a water molecule, and water is a polar molecule because oxygen is more electronegative than hydrogen. So the oxygens are delta negative and the hydrogens are delta positive. And a hydrogen bond is going to form between the delta minus nitrogen and the delta plus hydrogen on a water molecule, and they're also going to form between the delta plus hydrogen on the amine and the delta minus oxygen on the water molecule. Now oxygen's got two lone pairs, so notice that I've put one of the lone pairs contributing to the hydrogen bond here. So the other lone pair on that oxygen could form a hydrogen bond to another amine molecule. So I'm going to draw a hydrogen bond forming now between the delta plus hydrogen on water and the delta negative nitrogen on another amine molecule. And I'm going to draw methylamine in here, because when a amine dissolves, just like other organic molecules, the water molecules get between the solute, the amine molecules. So notice I put one lone pair on the nitrogen and the delta minus charge on the nitrogen, and I'm forming a hydrogen bond here between the other lone pair on the oxygen and a delta plus hydrogen on the amine molecule. So that diagram would show why the primary amine, methylamine, dissolves in water. So in terms of the awarding of marks, I would give 1 mark if the dipoles were labelled correctly. So in other words, delta minus on the nitrogen, delta plus on the hydrogen bonded to the nitrogen in the amine, delta plus on the hydrogen of water, and delta minus on the oxygen present in water. I would also give 1 mark if you had the correct interaction. So in other words, the delta plus on a hydrogen of water bonded to the delta minus of the nitrogen, and I would give 1 mark if you put in the lone pairs correctly. So that's how I would award 3 marks for that. So here's our last practice questions for you to have a go at. So read through the questions, pause the video, have a go at them, and then we'll go for the answers. So question 3 was asking you to explain why the solubility of primary amines decreases as the length of the hydrocarbon chain increases. So if you said that hydrocarbon chains are non-polar, there's a mark for that. And the longer the non-polar hydrocarbon chain, the more it disrupts water's ability to form hydrogen bonds to the amines NH2 group. There's a mark for that. And then for part B, it's asking you to explain why phenylamine is not very soluble in water, and it's because phenylamine contains a large non-polar benzene ring, 1 mark for saying that, and this disrupts water's ability to form hydrogen bonds to the amines NH2 group, 1 mark for that. So that concludes this video lesson. So after watching this video, you should be able to use the IUPAC rules to name and draw the structural formula of amines and be able to classify the amines as either primary, secondary or tertiary. You should also understand the intermolecular forces present in amines and how these are linked to physical properties such as boiling points. And finally, you should be able to explain why amines with short hydrocarbon chains dissolve in water and why increasing the hydrocarbon chain in an amine reduces this solubility. So that concludes this video lesson. So please check out our YouTube channel, Dr. O Chemistry, which has lots of GCSE, AS and A-level videos, and our Twitter site @Radachemistry.